X squared plus 3.
Better. We better get x squared plus 3 or we got nowhere else to go. Right? It's only because we get x squared plus 3 again that we can take out the common x squared plus 3. So I should be working smart as well as hard, right? Because x squared plus 3, that's a help. But if I don't get another x squared plus 3, I'm finished. So yep, I better get another x squared plus 3. Which means, what do I have to take out of this in order to get positive x squared plus 3?
Negative 3.
Negative 3. Very good. Everybody okay? Now, I bet you traditionalist people over here, what are you getting in your parentheses? 2x minus 3? Uh-huh. See what's going to happen? We're going to get 12 times, we're going to take out the common factor now. X squared plus 3 is a common factor. 2x minus 3 is what's left over. You guys took out the common factor of 2x minus 3, and you found that x squared plus 3 was the remaining factor. Either way, same thing, right? Didn't matter which pair of factors we put together. Hey, as long as you can see something they got in common, go for it.
It doesn't matter if we use brackets or not.
The brackets here are not necessary.
Okay.
Brackets here might be kind of helpful because I got parentheses. You can put parentheses with parentheses. It just gets kind of, a little bit confusing. So yeah, the brackets here in the last answer are not necessary. It's just 12 times that times that. Question? Try in other. Let's go traditional this time. A3 minus 3a squared. Common factor of, right here? A squared is the common factor. And I want to get a minus 3 in the parentheses, so what do I take out? Negative 2. Now you realize I could take out a positive 2 legitimately, but that would give me negative a plus 3 in my parentheses, not a help. So I want the exact same thing, a minus 3, to show up again. In order to do that, I've got to take out a minus 2. Oh. Sorry. And just to make sure, just go back and distribute. Negative 2 times a, negative 2a. Negative 2 times negative 3, positive 6. Yep, it works. And here's once again where you have your aha moment. You go, a minus 3 shows up twice. It best show up twice. And a squared minus 2. By the way, who had the original eureka moment, the original aha moment? Where did the phrase come from? Eureka, or what does it mean? Who had the original eureka moment? It's not the inventor of the vacuum cleaner. No. Einstein, well before him. Edison, well before him. He was wearing a toga, probably. Actually, wasn't wearing anything at all. Yes, ma'am? You just don't understand this. Okay, forget the eureka moment. All right. You don't understand this? So it didn't seem that complicated till I started doing it? Hey, why don't you come up here and say that again, all right? Come right here. No, I'm kidding. You want to come up on the front? Well, let's look at an example, all right? This was kind of complicated, so let's look at this guy. All right, let's start at the beginning. 4 terms says, let's go with factoring by grouping, okay? So you group, in other words, put them together. You group terms based on something they have in common. In other words, I see those first 2 have something in common. They both have an x squared in them, so I'm putting these guys together. These guys both have a 6 in them, so I'm putting them together. Then you factor out what you saw that they had in common. In the first group, an x squared. In the second group, a 6. So I take out that x squared out of these 2 guys. I take the 6 out of these 2 guys. And I just still have another expression. I've just factored a little bit of stuff out. But here's where I go back to this example from standard number 1, from technique number 1. If I have a polynomial that has a common binomial factor, I can take that binomial factor out and just multiply it by what's left. In this case, a plus c. So that's what we're doing every single time. We're going to end up with a common binomial factor. Take it out. Here it is. What's left? X squared plus 6. Okay? Okay. Hey, that's technique number 2. Yes, ma'am.
This might be a dumb question, but on the second one, had you just failed to realize that 12 is a common factor, would you just suffer through larger numbers until the end?
And then take out the 12.
Everything would still work out.
Here's what you would have done. You would have, like you said, suffered through larger numbers, but then you would have gotten something like this. Where's our... You would have gotten something like this. You would have gotten x squared plus 3 times 24x minus 36. That's what you would have gotten right there. And then you would have said, well, hang on just a second. These guys still have a common factor. So let me take out that 12.
So even though there's not a 12 in both of the terms, you can still take it out?
Absolutely. Yep. Oh, yeah. Absolutely.
Because I was like halfway through when you said the 12, so I didn't.
Okay. Yeah, if you forgot to take it or didn't see to take out the 12, you're not, messed up completely. So at the end, the 12 is going to come out eventually. So it's one of those pay me now or pay me later type things. All right, technique number 3. Difference of 2 squares. Hey, every time you see this one coming along, you ought to think you're lucky stars because this is easy. Difference of 2 squares is easy. Do you remember when we multiplied binomials last time we were together? Talked about polynomials, started multiplying them. We multiplied one example that looked like this. You remember doing that? They look identical except for the sign in the middle. And then we made an observation. Hey, what happens when I FOIL this guy? It's x squared minus 5x plus 5x. Oh, opposite. Oh, minus 25. So the O and the I, just like in the multiplication of conjugates, the O and the I are out of there. And I get what we commonly call the difference